Hello everyone, I'm Tejal Dave. I'm going to explain you gain margin and phase margin from BodePlot and stability concept from BodePlot. Let us see first of all the definition of gain margin and phase margin. Gain margin is the margin which we can add in the actual gain of the system, and the system will still remain stable. So that means you can add or decrease the gain of the system by a margin defined by a gain margin, and the system will still remain stable. It is normally expressed in a unit dB. Phase margin is similar to a gain margin. You can add this much phase or decrease this much phase defined by a phase margin in the system without making the system unstable. So it is usually expressed in degree. Now, how to find out the gain margin and phase margin from a Bode plot of any of the system? There are two frequencies. One is phase crossover frequency and another is a gain crossover frequency. They are defined in short as a GCF and PCF. So they are the frequencies at which the gain and phase of the systems are critical. That means if the gain of the system is 1 or 0 dB in a magnitude plot, this frequency is known as gain crossover frequency. Similarly, it refers to the frequency, the phase crossover frequency is the frequency at which the phase plot curves crosses minus 180 degree axis. Similarly, so these are the two frequencies defined in radian per second. Normally, the gain margin we find out by taking a reference of PCF. So we find out the gain margin of any system from PCF, and we find out the phase margin of the system by taking a reference of GCF. Now let us see how to find out GCF and PCF from the actual Bode plot of one system. The system here I have taken 10 by S, into S plus 2, S plus 5. It's a third order system, type 1 system having a gain of 10. You see here the gain of 10. Now in this particular system, Bode plot, which you can easily derive from a MATLAB by entering a transfer function and by a command known as Bode. So there are two frequencies known as GCF and PCF that we have to look at first. So what is GCF? GCF is the frequency at which the magnitude plot crosses or intersects this 0 dB. Similarly, the PCF is the frequency at which your phase plot, here you can see this is the phase plot, it intersects this minus 180 degree at this frequency. So this is known as, let us write down GCF, and here this is PCF. Now from PCF, we take a reference on a gain plot and find out how much margin is there that you can add in the system, and still the magnitude remains at this, it will not cross 0 dB. So here this is a margin, and how much margin you get? This is known as gain margin. If your magnitude plot is below 0 dB, then your gain margin is positive. Similarly, from GCF, we take a reference on a phase plot, and how much margin is there? This is known as phase margin. If your phase plot is above minus 180 degree, then your phase margin is positive. So this way we can find out GM&PF and GCF and PCF. Now let us see if we draw the Bode plot of the system, same system with a different gain. So here I have taken gain of 30, and you see that in this case the GCF and PCF are same. GCF and PCF are same. So in this case you do not get any margins. This GM is become 0 dB and phase margin is approximately 0. Right? It is 4.6 into 10 raised to minus 7. So it is 0.0000. So it is approximately 0 degree. So you see that here we don't get any margin to add in the system. The system is defined here as a marginally stable system. Similarly, in a third case, I have taken a gain of 50. So we had seen already at the gain of 30, the system was marginally stable. And we have increased still the gain of the system. And we have taken 50. In this case, you see that the gain margin and phase margin are negative. Right? So gain plot is above 0 dB and phase plot is below minus 180. So in this case, you get gain margin and phase margin negative and system would be unstable. If you draw the step response of the system, it would show you that the magnitude of the system increases unboundedly as time increases. So the system behavior is unstable. So in short, we can state the stability conditions from BodePlot now. If both the margins are positive, or if you see the hint phase margin is greater than gain margin, the system is stable. And in this case, GCF will be lesser than the PCF. Similarly, if your GCF equal to PCF, both margins are 0 and your system is known as marginally stable system. For unstable system, you will find out that any of these gain margin or phase margin is negative or both are negative, the system is unstable, and you would observe that the phase margin is lesser than the gain margin. So here we have seen how to find out GCF, PCF and what is GM&PM and how to derive stability from the BodePlot. Thank you all.